Welcome to this video. So I'm excited to create this video. So despite everything that happened when I was trying to create it, the other ones I was trying to do was deleted. Let's do this now. So our topic is a topic on chemistry, that is electrochemistry. So it means electrochemistry is not only on electrolysis, it is both on electrochemical and electrolysis and what and electrolysis. So but mainly in this video we are going to be talking on electrolysis, so I'm going to still be making some video on maybe on electrochemical cell. Now let's talk about electrolysis. What's electrolysis? Electrolysis is the chemical decomposition of a substance sorry, this one should be gas, this will be substance, sorry about that, of a substance when electric current pass through it in a molten or solution, or it can also be aqueous form. So now what is the function of electrolysis? So electrolysis, what happens in electrolysis is that electrolysis converts electrical energy to chemical energy. Now let's talk about the terms in electrolysis. So these terms, you need to please take note of them. And what is the first term you should note? It is called the anode. So the anode is the positive charged electrode. So we have electrode in an electrolyte that is dipped into it. It's an electrode. Now let's talk about anions. Anions are negative ions that moves to anode. If you look at the word anion, so it means ions that move to the word anode. You understand? So anions. Don't forget it is what? Negative ions. And why does it move? I'm going to be telling you later in this video. Now let's talk about cathode. So cathode is negatively charged. Sorry, it should be negatively charged electrode. It should be positively charged electrode. Now, what are cations? Now you know that cathode is negative. So cations will now be what? Positive. And why is it that positive ions is moving to cathode, which is negatively charged? Don't forget that law in physics that says like charges repel and unlike charges what? Attract. Like charges repel, unlike attract. Don't forget. So don't forget, unlike attract. Now what are like charges? Plus and plus, they are going to repel. Plus and minus, they are going to attract. So it means since anode is positive, negative ions is going to be attracted to anode, because that is what? Attraction. Cathode also is negatively charged electrode. Because it is negatively charged, the ions that will move to cathode must be what? Positive. I hope you understand. So that's the logic we used to do them. I'm going to explain better now. Now let's talk about electrode. What are electrodes? Electrode is the terminals of the electrolytic cell. So we have two types of electrode. We just have the anode and the what? Cathode. So anode, I've told you earlier on that anode is the positively charged electrode. Cathode is the negatively charged electrode. Now you should notice that most of the time the substance we normally use as electrodes, they are conductors. Metals like, what are conductors? They are substances that conduct electricity easily. Now metals, so we use some substances like platinum as our conductors for electrodes. We use platinum, we use copper, we use mercury, or non-metals like graphite and allotrope of carbon. So they may tell you at times that we use carbon electrode as what? So if they say carbon electrode, they are still telling you is what? Graphite electrode. So now let's go to electrolytes. Electrolyte is the compound that breaks up into ions when aqueous solution. Okay, sorry. When electric currents pass through it. Sorry for making some mistake. When electric currents pass through it. So that's it. Now what are examples? Examples of electrolytes are mineral, acids, alkalis and salts. Now let me tell you this before we go on, because if I don't tell you this, it will be as if I didn't do anything. So this is it. So we have types of electrolytes. We have types of electrolytes. So the first thing is the strong electrolytes. So what are strong electrolytes? So strong electrolytes are electrolytes that dissociate into ions completely. So e.g. they are what? Strong acid. All those strong acid, they are strong electrolytes. Strong acid like hydrochloric acid, tetrasulfuric acid, HNO3. So these are for your own level. These are the strong acids. Now let's talk about another one. They are what? Strong base. The example of strong base, they are NaOH, and which is sodium hydroxide, and potassium hydroxide, KOH. So and also we also have what? Salts. So and these salts, they are what? They are normal salts. Please take note of that. They are what? They are normal salts. Now e.g. sodium chloride, NaCl. Those are examples of what? Strong electrolytes. Please take note of that. They are electrolytes that dissociate into ions completely when they are dissolved in water or aqueous solution. Now let's go to weak electrolytes. So weak electrolytes. So you should know what it will be like that. Weak electrolytes, they will now be what? Are electrolytes that dissociate partially. That dissociates partially. So the reason why I wrote the ones that we have done down is that so that it can reduce the time we are going to use. So our electrolyte that dissociate partially in aqueous or solution form. So they dissociate partially when electric current passes through them. Don't forget that. So the example is a weak acid. Don't forget. Example of weak acid: H2CO3, ethanoic acid, which is CH3COH. That's ethanoic acid. We have methanoic acid, CHCOH. That's methanoic acid. Let's talk about. Then we also have weak base. Weak bases like ammonia, which is NH3. These are weak base. So things like that. Okay, Na2CO3. So very weak base, and so on and so forth. So etc. So we also have salts. Most of the time, the salts that we use as weak electrolyte, they are insoluble salts. Most of the time, they are what? Insoluble salts. Now let's continue. Now we have non-electrolytes. So in electrolytes, they are the electrolytes that don't dissociate at all in water. So example is like detergents, all those things like that. So they don't dissociate at all. It's like saying methane now. Methane cannot dissociate at all in a what? Solution state. I hope you understand. Now let's go to things like petrol also cannot be kerosene, grease, all those things, they cannot be. So write that. So let's continue. So now they now say the power source of an electrolytic cell is a battery or a direct current. Direct current is different from alternating current. So the power source of an electrolytic cell is a what? Battery or an direct current source, and not an alternating current AC source that pass through it. So take note that it is a battery that's a source for a what? Electrolytic cell. So now let's continue. Now this is the diagram for a typical electrolytic cell. Now you should know is that we have two types of electrodes. I told you earlier that we have anode and we have cathode. Do you get? Now don't forget that anode is positively charged. I hope you understand. And cathode is what? Negatively charged. Why the solution is the what? Electrolytes. And the electrode is both the anode and the cathode. Don't forget the anode is positive type. Most of the time, when you see a diagram of an electrolytic cell, most of the time you will find it at the left hand side, while the cathode will be at the what? Right hand side. Now we have the switch. So this is the switch, and this is the battery source. So power source DC. So this is the battery. So this is the battery. I hope you understand that. Now let's go to electrolytic process involve 3 steps. Now the first step is ionization of electrolytes and water. So if aqueous solution or electrolyte alone, if in molten form. So ionization of electrolyte and water, if aqueous solution or electrolyte alone, if in molten form. Now what they are saying is whenever it is ionization of electrolyte, when it's in aqueous form, when you are writing it, you will put water below. But if it is molten form, you're just going to write just the electrolyte. This is just the electrolyte. Don't forget. Now what is CuSO4 going to dissociate to? So CuSO4 is going to dissociate to since it is copper 2 tetrasulfate salts. Copper 2, it carries Cu2 plus on itself, so it will be Cu2 plus SO4 2 minus. Please take notes. Whenever we have copper 2, that's how we will write it. Now for H2O, it will be what? H plus OH minus. I hope you understand. So that's how it will be. Now let's continue. Let's go to the next slide. Now for a molten, you don't need to put water below. I hope you understand. So that's the difference between molten and aqueous. If it's aqueous, we put water below. But most of the time, it is the aqueous you will be using. Most of our questions you will be doing, you will have to put water below. But whenever it is molten, you just say PP. And lead is what? Because look at this. This is lead. This is how we produce lead bromide. Br2, Br minus. This is what? 1 minus, right? So it means 1 will come here, 2 will go here. So it's now what? PP Br2. So that's how we are getting their compound. I hope you understand. So you need to know valency. If you don't know valency, you may find it difficult, this topic difficult. So we have PP2 plus Br minus. So it has dissociated like that. Now the ions produced here move at random within the electrolyte since the switch is not yet on. So the ion will be moving what? Moving randomly. Don't forget that we have 3 processes in electrolysis of a compound. The first process is ionization of electrolytes and water. So that's the first process. Now the second, we go to the second procedure now. So this second procedure is ionization of ions to the electrodes. So this occurs when the switch is on. So don't forget, when the switch is on. Now the positively charged ions migrates to the cathode. So I've told you earlier on that positively charged ions, they are what? Cations. While negatively charged ions, they are what? Anions. So anions will migrate to anode. Cations will migrate to cathode. Now let's write the equation for this reaction. So it will now be what? Cu2 plus. Don't forget, that is how we write it. Don't forget to be in what? Aqueous form. Don't forget water will be always H plus OH minus. So let's continue. Now let me tell you, there's something I should tell you there. So this is the words. If you are following, you should know that this is your words, cations. This is your words, anions. Now what will happen? Cu2 plus being the anion and H plus, we move to the cathode. Why OH minus and SO4 minus, SO4 2 minus, we move to cathode. I hope you are getting it. So that's it. I hope you understand. So let's continue. Now let's go to discharge of ions in the electrodes. Now, when you're talking of discharge of ions is how those electrons, how those elements, how those ions, how they discharge at cathode and anode, how they discharge at cathode and anode. Now this discharge actually involves a gain of electrons at the cathode. So it means at cathode, what occurs? Reduction occurs at cathode. While at anode, what occurs? Oxidation occurs at what? At anode. And what is the meaning of oxidation? Oxidation is what? Loss of electron. Why reduction is the gaining of what? Electron. Now, so it means discharge of ions is what? It's a redox reaction. And what is redox reaction? You see the word redox. So read represents reduction. Ox represents oxidation. Now you should know this acronym. That for cathode, CRAO. So the acronym is that at cathode reduction occurs, at anode oxidation occurs. If you don't know this simple logic, you're going to find this topic difficult. But I pray you will not find it difficult. Now this we are using a what? Molten silver bromide as an example here. I hope you understand. So we are using what? A molten silver chloride here. Now this is the equation for the reaction. You show that it is molten. The reason why it is molten is that I don't write water below. When I said aqueous, I'll be putting water what? Below. So it now be what? For me to write Pb, it will now be Pb2 plus Br minus. So that's how it will be. Now, don't forget that there will be nothing like water in this reaction. So it means this only will go to the what? This is positive charge, so it will go to the what? Cathode. So Pb2 plus. And don't forget what happened in cathode. Cathode is reduction, so it means it's going to what? Gain electron. Gain electrons means we're going to add 2 electrons. Why did I write 2 electrons? Because it carries just plus. Do you get what I'm saying? Adding mate is what? Na plus, like sodium. Now I'm going to write 3E minus. I hope you understand. So it is the number of charge it carries. I'm going to write here. Adding bit is aluminium. It will be plus 3E minus. Do you get the logic? So it will not be what? AL. I hope you get. Do you get? So that's how it will be. I hope you understand. So it is the number of things they carry. I'm going to put here. I hope you understand. So that's how to do it. Now for lead now, that's what I'm going to apply. So it will not be what? Now since it has gained electron, this electron is going to, this ions is going to remove. It's now going to become PPS. I hope you understand. Now I have done that of cathode. I will do that of what? I will do that of what? Bromine now, which is going to what? To anode. So bromine now will be what? Br minus. Now they told us bromine, it loses at oxidation. There is what? Loss of electron. Now instead of us to add electron, since it lose, when you lose, maybe you are selling something and you lose, it means you are minus. I hope you understand. So instead of now saying plus 2E minus, if you look at it, it just carry minus. I hope you understand. It carries just what? Just minus. I hope you understand. So it means because it carries just minus, it will be what? Just minus E minus. I hope you understand. Minus because it is what? It loses electron, because oxidation in human cell normally happen in what? In anode. Please sorry for that. So normally happen in what? Anode. So Br minus minus E minus, which will not be what? Br. Now bromine cannot start alone. You should know that. That what? Bromine cannot what? Stand alone. Bromine is a gas. It cannot stand alone. So you are going to put what? 2 here. Don't forget, chlorine cannot stand alone. Oxygen cannot stand alone. They are diatomic gases. Hydrogen cannot stand alone. If you are writing equation, you can see them writing hydrogen singly. So that's why we are not going to say Br2. I hope you understand. So now, what are you going to do? Now we have 2 bromine here, and we have bromide ion here. Just 1 bromide. So for us to balance the equation, we are going to put 2 here. Now, since we have 2 bromine here, it means the number of electrons we are going to have here to be what? 2 times minus 1. I hope you understand. So this place is going to become minus 2. So it means our electron now cannot be E minus again. It must now be what? 2. I hope you get the logic. Now, this is chemistry. It is very wrong for us to put minus in our. So because of that, let's bring this to this side. So it will now be 2br minus into what? br2 plus 2e minus. Do you get? So that's how it will now be. I hope you understand. Now let's try. I will give you this platform. Quickly do this. Let's do a lot of things so that it will not be as if we are just brushing things up. Now, adding B, they give you that of chlorine. Chlorine now is in what? It's at anode. So it will now be Cl. You can quickly pause the video and quickly do that. So it will now be Cl2 E minus. It will give you, sorry. Chlorine is going to carry minus. So minus E minus, don't forget. So chlorine, don't forget, chlorine cannot stand on its own. So we write Cl2. To balance, we will put 2 here. Chlorine cannot, it will now have 2 electrons because 2 times minus 1 is be what? Minus 2. So you will put what? 2 here. In chemistry, for us to be putting minus, it doesn't make much sense. So it will now be 2L minus into Cl2 plus 2E minus. You can try that of oxygen. Oxygen O2. Okay, that of oxygen is quite different. Let's try that of which element is that? Okay, iodine. You can try that of iodine. So that will be what? Don't forget minus I2. Don't forget what we are going to do. Put 2 here. Put 2 here. So bring this to the other side. So it's very simple. 2I minus will now be I2 plus 2E minus. So it's like opposite of cathode. So that's how to do it. Now don't forget Br2 is on this side, so it means bromine gas, right? So your face here will be bromine gas. Do you get? So let's continue. Now, for cases where two different ions having the same charge type migrate to an electrode. Now, since two ions are migrating to a particular electrode, they must. So one of them must be the same. For example, if you are working in an organization, one of you will be the senior, while the other may be the junior. I hope you understand. So it's just like these ions also. When they get to the anode or cathode, one of them must bow down. One of them was discharged. So that's now we now see that for cases two different ions having the same charge type migrate to an electrode, one of the ions is selected for preferential discharge. So now the selection of ion for preferential discharge by an electron is based on some factors. Now we have 3 factors for ions of preferential discharge. Now the first factor is position of the ion in the activity series. The second is nature of the electrode. The third is concentration of ions. Now the most important, most of the time, except if they want to trick you, that they will use concentration and nature of the electrode. Most of the time it is the position of the ion that determines. Now position of the ion in the activity series. An ion lower in the activity series is selected for preferential discharge over the one above it if the solution of the electrolyte is what? Dilute. So this is where concentration of ions comes in. I'm going to be explaining that later. Now, position of ion in the activity series. So what happened is in the activity series, I'm going to show you the diagram now, and I will give you the mnemonic. So what happened in activity series is that any ion that is above, it is powerful than the ion below. So the ones that is below is going to discharge, that is going to bow down. Hope you understand. So let's continue. Now this is the formula for the activation series. The mnemonic is popular scientists can make all zoo in the low humid country more satisfactory good. You get? Let's try it again. Popular scientists can make all zoo in the low humid country more satisfactory good. Oh, I brought chlorine number 7 chlorine. Let's try again. Oh, I brought chlorine number 7 chlorine. So that's what this is chlorine. This is chlorine. Is the element with the highest electronegative. So Let's go to the mnemonic again. Now this is the mnemonic. Popular, that is potassium. Scientist, sodium. Can, calcium. Make, magnesium. All, aluminium. Su, zinc. In, iron. Low, lead. Humid, hydrogen. Country, copper. More, mercury. Satisfactory, silver. Gold, gold. So electronegative. I brought chlorine, number 7 fluorine. O is hydroxide ion, iodide ion, bromide ion, chloride ion, nitrates 3 ion, sulfur 6 ion, and fluoride ion. So let's continue. So if you know the mnemonic offhand, so that you can know the activity series. Now for instance, Cu2 plus and H plus. Now let's go to the activity series. If you go to the activity series now, this is the activity series, right? You can also call it electrochemical series. Now, if you look at this, they said which one is going to discharge between hydrogen and copper. Now, if you look at this is hydrogen, this is copper. Hydrogen is higher than copper. Which one do you think is going to discharge? I've told you the one that is lower is going to discharge. So copper is going to discharge. Do you understand? What if it is between potassium and magnesium? Potassium is higher than magnesium. Magnesium is going to discharge. Do you get? Now, what of chlorine and sulfates? No, let's say, if you see this, the gap is even much wide. So it means between sulfate 6 and hydroxide. If you look at it, which one do you think is going to firstly discharge? So this one is higher than this. So this one will discharge. Do you understand? So let's continue. So now you see it now. So in an electrolysis cell, so Cu2 plus being lower than H plus in the activity series is selected for preferential discharge if the electrolytes, so there is a condition. If the electrolytes are dilutes only, that's when Cu2 plus will be what? Discharged. Now let's go to concentration of electrolytes. This concentration of electrolytes, what is going to happen is that there is what will happen when the ion is what? When it is dilute and when it is concentrated. Now this is what is going to happen. For an increase in the concentration of an ion due to increase in the concentration of the electrolyte may tend to reverse the order of discharge stated by the activity series. Now for example, both chlorine and hydroxide ions migrate to the anode in the in the electrolysis of what? Concentrated HCl or NaCl solution. You know that normally between chlorine and OH minus, OH minus what? Should discharge. But because the solution is what? Concentrated. I hope you understand. Because the solution is what? Concentrated. Instead of hydroxide ion to discharge, the chlorine what? Will discharge. I hope you understand. So because why is it that chlorine discharge? The reason is that the concentration of chlorine is what? Is overwhelmingly the greater of the two. So chlorine is discharged in preference. However, if the acid or salt solution is dilute, so adding being it is other way around, some discharge of OH minus will also what? Occur. As the acid is diluted further, a mixture of two gases, Cl2 and O2 will come up, with the proportion of O2 gradually what? Increasing. So this is what they are saying, that adding being that concentrated salt, NaCl or HCl, we are now pouring water inside, we are now diluting it. So it means Cl minus will not discharge again. It is OH minus that will be discharging. And when OH minus discharge, it will be leading to the what? Evolution of oxygen. Now let's go to the nature of electrode. Now, in nature of electrode, we have what we call inert electrode. Most of the time, the inert electrode we have is carbon electrode or graphite electrode and platinum electrode. Those are the inert electrode. Now, the nature of electrode used in electrolysis may sometimes influence the selection of ion for preferential discharge. This can be illustrated with the electrolysis of a solution of what? Sodium chloride. So if platinum cathode is used, so this is an inert electrode. Platinum, I told you that platinum is an inert electrode. So if platinum cathode is used, H plus being lower in the activity series than Na plus. If you look at Na plus, is on the top while hydrogen is below. And platinum is an inert electrode. Here, what I mean by inert is that it doesn't have effects on the what preferential discharge. But if it's not an inert electrode like mercury cathode, now it's not an inert electrode. So normally it will occur normally, since Na plus is higher than H plus. H plus is going to what discharge. I hope you understand. So the product will be what? When hydrogen discharge, just note that whenever hydrogen discharge, hydrogen gas will be what? Formed. I'm going to be writing the equation if time permits me. Now with mercury cathode, Na plus is selected for preferential discharge to form what? If we now use mercury cathode, and you know that mercury is not an inert electrode. So with mercury cathode, Na plus is what selected for preferential discharge. Why is it that we chose sodium, despite the fact that sodium is higher than hydrogen? The reason is that sodium is going to react with mercury to form what? Sodium amalgam. So sodium amalgam is an alloy. So it is easier for it requires less energy for sodium to combine with mercury, because sodium love mercury. Both of them, they fall in love. I hope you understand. So it's easy for sodium to fall in love with mercury than for hydrogen to fall in love with mercury. So it requires less energy for sodium to combine with mercury. So instead of hydrogen to discharge, sodium will what? Will discharge. So sodium is selected for preferential to form sodium amalgam with the mercury, because it will require less energy than the discharge of H plus to form hydrogen gas. Now let's quickly try some things. Now what we are trying is electrolysis of dilute tetrasulfate 6 acid, that is electrolysis of water. So whenever they ask you that what's the electrolysis of water, it is also called the electrolysis of dilute tetrasulfate 6 acid. Now the apparatus we are going to be using is what is called the Utme voltameter. Now the ionization of the electrolyte and water is shown below. Now you should know the ionization. So this is the ionization. Now don't forget, whenever we are writing the ionization, it will be H plus SO4 2 minus. Now don't forget, we have 2 hydrogen here. We are going to be having 2 hydrogen here. And here also we are going to be having H plus OH minus. What do you notice as a chemistry student? H plus is here, H plus is also here. So automatically both of them, they are the same thing. So it means H plus is going to discharge. I hope you get the logic. So it means this one is what? They are going to what? They are going to cathode. This one, because they are positive. This one also, they will go to what? Anode. So you say H plus and H plus, they move to what? To what? To cathode. Now what is going to happen? Since both of them, they are both hydrogen. So hydrogen will discharge. And whenever hydrogen discharge, what happens in cathode? What happens in cathode is that gain of electron. So it will now be H plus E minus into what? Hydrogen. Now I told you that hydrogen is diatomic gas. Do you get? So it cannot start alone. So it will not be hydrogen gas. I understand. Now we have 2 hydrogen here. We have 1 hydrogen ion here. So here we are going to be having what? 2. I understand. Now since we have 2 here, I understand. We have 2 hydrogen here. So it will become plus 2 electrons. So it means I must put what? Plus 2 here. I understand. The reason why we have this is that we are having plus 2 here. Now what's going to happen is that the oxidation state of hydrogen is what? Is 0. Any element that does not combine with other elements is what? It has an oxidation number of 0, because hydrogen is not combining with anything. It is 0. But HCl is different, because hydrogen has combined with chlorine here, so the oxidation number will not be 0. I hope you understand. But here, hydrogen has not combined with anything. The oxidation number is 0. Now, when we say something gain 2 electrons, so it means 2 minus 2. I hope you understand. Now, what is plus 2 minus 2? So it's what? 0. So our equation is what? Balance. I hope you get it. So this is how to do it. So this is gas. Now at the anode, though both SO4 2 minus and OH minus migrate to this electrode. So what is going to happen? OH minus is lower to SO4 2 minus. Don't forget. So let's quickly check. So you can see it's OH minus is lower to SO4. You can see the gap. So OH minus is lower. So OH minus is going to what? To discharge. So though both SO4 minus and OH minus migrate to this electrode, only OH minus discharge. So you know the reason, being lower in activity series. Now what is the reaction? So this reaction is very important. Whenever OH minus is discharging, just know it's offhand. I won't tell you the logic because we're going to waste a lot of time. If I say I will be doing the logic, just know that whenever OH minus discharge, this is the formula. Just say for you say that I do it offhand. Just know it's offhand that whenever OH minus discharge, what is going to happen? 2H2O plus don't forget, so we are going to be having 4E minus. I hope you understand. So whenever OH minus discharge, remember this formula. Always you can commit it to your memory. That's what's going to happen. Now what are our products? Water is our product, oxygen gas is what? Our product. So at cathode here, what's our product? Hydrogen gas. So you will say hydrogen gas is liberated at what? Cathode. It's liberated at cathode. So they will just ask you that what is liberated at cathode in electrolysis of water. Just know it that hydrogen gas is what? Liberated. Now here, oxygen is our main gas. So you will say oxygen is therefore produced at this cathode, at this electrode. So the discharge of OH minus disturbs the ionic equilibrium of water. Hence, excess H plus ions are produced. That is, acidity increases at this electrode. Let's continue. So the electrolysis demonstrates the composition of water. That is, 2 volumes of hydrogen is cathode and 1 volume of oxygen at the anode. Don't forget, if you look at the question, we produce what? 2 volumes of hydrogen. Do you see it? H2. We also have what? 1 volume of what? Oxygen. So what happened is that the hydrogen forms in what? This is what we are using at this experiment to demonstrate that we are going to get water contains 2 volumes of hydrogen and 1 volume of oxygen. So that's what we are using it to demonstrate. So that's why we get water. So let's continue. So also the total acidity at anode and cathode together what remains constant. Now let's go to electrolysis of aqueous copper 2 tetrasulfate 6 solution. So using copper or platinum cathode. Now copper and platinum cathode, now there's going to be a little bit difference now, and platinum or carbon in anode. Now don't forget, do now what? Cu2 plus, don't forget SO4 2 minus. Don't forget, whenever we're having this Cu2 plus. Now don't forget, these ones they are what? They will go to anode, go to a negative charge, and anode is positive. This also what? They will move to cathode. Why are they now? They move to cathode. Now what is going to happen? According to what I taught you need to know what is going to what? Anode. Now, do you know that Cu2 plus is lower to hydrogen? So again, copper is going to what? Discharge instead of hydrogen. That you can still go and look at it again. Do you see now? This is hydrogen and this is copper. Hydrogen is higher than copper, so copper is going to what? Is going to bow down for hydrogen. I hope you get the logic. So the ones that is lower is going to be what? Discharge. Now so both of them they move to cathode. So hydrogen is discharged, copper is discharged. So to now be what happened in cathode? Gaining of electron. So you will be what? 2E minus. So we are going to be having just copper. It is when we have gases that we will be balancing it. I hope you understand. So this will be Cu2 plus 2E minus Cus. So this is the cathode. Now those copper deposits as a brown layer on the cathode, and blue solution of the blue solution will be what? Fading, because copper is discharged, and copper has what? Copper 2 has what? The blue color. I hope you understand. Now let's go to the anode. Now what discharge at the anode? What discharge at the anode? This SO42 minus and OH minus, they go to the what? And now what is going to discharge? So SO42 minus and OH minus. So you know that OH minus is lower to SO42 minus. So now what do you think is going to happen? So OH minus will what? Is discharge. And I told you the reaction whenever OH minus discharge, the reaction will always be what? 4OH minus. I've told you that whenever OH minus discharge, it will be 4OH minus plus O2 plus 4E minus. I hope you understand. So it will be 4OH minus 2A2 plus O2 plus 4 electrons. So this is the reaction whenever OH minus what? Discharge. Because it is what? Lower in it. So don't forget oxygen, this is oxygen gas. So it's good, it is what? Liberated at this level. So this discharge of OH minus leads to the production of excess H plus ions. Since the ionic equilibrium of water is disturbed, hence the level of acidity increases at this electrode. Now let's go to this one. Is different from all of them. So this is called the what? The electrolysis of aqueous copper 2 tetrasulfate 6 solution using copper electrodes. So here we use what? Copper electrodes, having copper 2 tetrasulfate 6 solution, and we still use what? Copper electrodes. So this one is what? Quite different. Now if you look at the things we have done, that, so don't forget that we will always be having Cu2 plus SO42 minus, and we also have what? H plus OH minus. So normally this is the anode, this will go to the what? Cathode. This will also go to the what? Anode. Now at the cathode, this is Cu2 plus, and don't forget, normally Cu2 plus is going to what? Discharge. So normally the Cu2 plus is still going to what? Discharge. So the Cu2 plus will also discharge again because it is lower in what? Electrochemical series. So what happened at cathode reduction? So you will add electron, gaining of electron. So we have CuS. I hope you understand. So that's the reaction for number one. So now at the anode, don't forget. Now this one is quite different. So and at anode, instead of the SO42 minus or OH minus to migrate to discharge, none of them will discharge. Do you see that? So that's why it's quite what? Funny. If you look at is this question, did they know what they are doing? So even though both SO42 minus and OH minus migrate to this place, none of them is selected for what? Preferential discharge. You can see that nature of electron is going to what? Affect. So instead, the copper anode itself dissolves and give its own what? Give its own Cu2 plus in what? Solution. This is due to the fact that less energy is required to do this. Then, to discharge any of the ions hitherto present in what? Solution. Now, this is the equation for reaction. Now, what do you think happened at anode? Oxidation happened at what? Anode. So it means if we are not going to be having Cu2 plus, it will not be what? It will not be minus 2A minus. You know that this is what? Anode. I hope you understand. So it is anode. You cannot be adding electron. So we have CuS. So you bring this to the side, other side. So we're now going to be having Cu2 plus. So we have Cus plus 2E minus. So this is the reaction for the equation. I hope you understand. So the opposite happened in anode and the opposite happened in the what? Cathode. Let's continue. Now we normally apply this equation in many things. So the copper 2 ions then migrate to the cathode for discharge. As time progresses, the anode copper diminishes in size. So the cause of this electrolyte process is the transfer of cathode from the anode to the cathode. The action stops when all the pure anode copper has dissolved. Now, dissolved and transferred to the cathode for deposition. Now, this principle of this electrolytic method is applied in what? Purification of some metals. An example is the purification of copper required for making copper wires. Now, the principle of this electrolytic method is applied in some. So we also use it in electroplating. Now let me quickly tell you the principle for electrolysis if time permits me. If you want to electroplate a sponge, assuming you have a spoon. If you want to electroplate it with sliver, I hope you understand. This is what you are going to use. You are going to use your spoon as the cathode. You will put it as what? As the cathode. You want to electroplate it with what? Sliver. Then you will use your sliver as what? As the anode. While your electrolyte will be what? It will be what? Sliver solution. I hope you get the logic. So this is how we electroplate. If you want to electroplate Precious, if Precious is the name of a person, if you want to electroplate it with Success, you will put Success in the anode. Then you will put Precious as the cathode. You will now use what? Precious, you will use Success solution as your electrolyte. I hope you understand it. So this is how to do what? Electrolysis solution. So we can just use sliver electrolysis solution. So we can just use any solution using it. I hope you understand. So that's for electroplating. So for that of purification of metals, you just say impure metal will be your anode, while your pure metal will be your cathode, and the solution of the pure metal